Now it's saying that I am live again without any of my stream. But it's not showing up in my preview. But I just don't get it. I don't know why this is such a difficult process. I have no issue doing live with the other live stream. But then now this one seems like it's working out. Okay. All right. So either way, I'm not sure, guys. I'm going to keep on playing with this, but I have a quiz that I need to go through. So please make sure you kind of jump ahead to this time, but I at least am recording this in addition to going live. So let's go ahead and get started. This is quiz number 1 for my analytic trigonometry. I do have some of you guys join in. Thank you so much. Just FYI, I just wanted to go over a quiz. I needed to do this. I just gave my students their quiz number 2 last week, and I never made the key for them on this quiz. So I was like, oh crap, I need to do this for them. So therefore, they will be prepared. So thank you very much for everybody joining in. That is awesome to see you. I guess I needed to hit live on the YouTube dashboard, and because not all you guys are coming in. So I guess the encoder didn't really work as much in that regard. So either way, but it looks like my audio and video and connection and everything's working out. So awesome. I did want to let you guys know I am not taking any open Q&A for this. I am just kind of talking right ahead of the stream because I wanted to get everything going over. It's actually kind of awkward. I don't have a big enough screen to be able to see actually your guys' comments, but I will try to, let's see, I can minimize that a little bit over. But yeah, so for such a big thing, I'm surprised I can't. No. Jeez. Cool. All right. Well, so what we're going to do is I'm going to just kind of cover this homework or this quiz from there, and then I'll just maybe say hi to you guys at the end. And therefore, but I am going to still be going live tonight at 9 p.m. Hopefully that one's still kind of scheduled on my page, so you guys can go ahead and see that. And we will just plan on doing that live stream at then, where I'll be able to take in your guys' questions. So if you do have some questions that you want to submit, you can go to my community post and make those submissions there. There's already some people that have already posted some questions. So I've already already have a list of topics that I'm going to plan on covering. But if you have something that you'd like to add in, then that would be great. Wesley, I do notice you, so thank you so much for joining in. Jack, RSG, Laura, my lovely wife, thank you. Crunchy Blend, AYN, Ramiro, Muhammad, Jack, Melly, Bree, Toasted Buns, your girl Kaylee. I'm not in trigonometry, but that's okay. So anyways, guys, let's go ahead and knock this out because, yeah, I don't want this live stream to be taking too much because I'm going to be going live again later this evening. But I do appreciate you guys joining in. Hopefully for those of you that are taking trigonometry or coming in, this will be a useful little live stream for you. And then again, guys, I'll stay after a little bit after this because hopefully it won't take me too long and we can get into the chat just for a little bit. So the first one is simplifying the expression to one single trigonometric function or number. So basically, what do you need to do? Oh, actually, crap. I forgot to change this. This doesn't work actually in that regard. This was actually supposed to be written as cosine of x. So my bad. I did grade it for my students as it was, but I actually meant to change that before I actually downloaded this new copy. But either way, we'll go ahead and do the key from there. So the reason why is when you have it as secant, it simplifies. It just doesn't simplify to one single trigonometric function or number. But if I have this as cosine, I can use the trigonometric or the cofunction identity, to rewrite that as a sine of x. Then in this case, I use the even odd identity to recognize sine of negative x is a negative sine of x, and then that's going to be tangent of x. All right. Well, obviously sine of x, guys, over sine of x is just going to be 1. So therefore, I'm left with 1 over a negative tangent of x, which now can be rewritten as a negative cotangent of x. All right, the next one is verifying an identity. Now, this one's a little bit similar to what we did for simplifying, but now we have an identity. So basically, we want to show that the left side is equal to the right side. And typically, the way that I taught this lesson was, find the side that's the most complicated, or at least find the side that where you can combine, apply some operations or apply some identities. So obviously I could multiply these, but again, if I want to show that the right side is to the left side, I don't really want to rewrite this as an addition of two fractions. I think it'd be a little bit easier to combine my fractions, therefore I can represent them as multiplication. So all I got to do is combine these fractions, but again, to do that, I have to have common denominators. So I recognize the denominators do not actually have a quantity in common. Like, yes, they both have a secant, right? But that's actually not a common multiple or a common value that divides into them evenly. So therefore, what we're going to do is just multiply these two products to find my common denominator. So really, all I need to do is just do a secant of beta plus 1. Then over here, I'll do a secant of beta minus 1. Now again, remember when you're doing this that you got to make sure you multiply the top and the bottom, because if you don't, then you're not going to produce what we call equivalent fractions. So you got to make sure you multiply the top and the bottom. Now my denominators are going to be the same. So I'm really just going to write what I have in the numerator, which is a secant of beta plus 1 plus a secant of beta plus 2. I'm sorry, plus 1 again. No, minus 1, sorry. Right, that's secant of beta minus 1. All right, in the denominator, I recognize that to be a secant of beta minus 1, or secant squared of beta minus 1. And then using my Pythagorean identities, what am I doing? Understanding my Pythagorean identities here, I recognize this to be tangent squared. If you remember your Pythagorean identity, 1 plus tangent squared of beta equals secant squared of beta. So if you subtract the 1, you can see how that's equal to tangent squared. I recognize I have 2 secants of beta, so we can write that as 2 secant of beta. And then 1 plus negative 1 ends up being 0. So therefore, I'm left with a 2 secant of beta divided by tangent squared. That's a squared as well, right? No, that's just regular. Tangent squared of beta. Okay. Now again, we want to show that that's going to be equal to cotangent over cosecant. So what I would typically do in this case is, instead of rewriting this as dividing by tangent squared, I would go ahead and rewrite this as a multiplying by cotangent squared. So let's go ahead and rewrite this in. So actually, really don't like doing this, but I kind of ran out of space here. So if I rewrote this as 2 times secant of beta times cotangent squared of beta. Okay, so now let's go ahead and continue this. I hate doing this. I wish I would have given myself more room. Let's redo this again over here. And then now what I'm going to do is I'm just going to write everything in terms of sines and cosines. So this would be 1 over cosine of beta. And this is going to be a cotangent cosine squared of beta divided by a sine squared of beta. All right, something's working out. What did I do wrong on this problem? Something's not working the way I want it to work. And I don't remember having a problem with this before. 2 cotangent cosine squared. Because that's going to go... Okay, well, I don't know. Let's divide these out. Maybe let's just work through the problem. And that's going to leave me with a 2 times a cosine. No, okay, that works out. Over a sine of x. I guess I just did it when I did my key. I did it a different way. Times sine of x. Yeah, okay, that still works out. So now the sine squared I can just rewrite as a sine times sine, and then I can just put the cosine over one of them. So therefore you can see you're left with now a 2 cotangent, not squared, of x times a cosecant of x, or beta. What am I doing? I got razzled. I got razzled there. Okay, over cosecant of beta. There you go. That one's identity. So typically, we like to always keep everything on the side. I had to use the arrows, even though I tell my students not to. But hopefully you can guys see. I mean, that one did require a little bit of work as well. And so therefore, that is what we do for verify identity. But again, you notice that I worked everything on the same side. And I applied the operations by combining them. And then I used my identities to help simplify. All right, the next free response question that worked on the quiz was find the solutions to the equation square root of 3 tangent of 2x minus 1 equals 0. And we wanted to find this on the interval of 0 and 2 pi. So the first thing I told my students to do here is just to isolate the trigonometric function. So this is a tangent of the double angle x, so it's 1. We didn't learn the double angle formulas yet, so we didn't go through that. Tangent of 2x is equal to the square root of 3 over 3. Now again, at this point, again, we didn't learn the double angles yet. We have now learned those. But again, I wouldn't even use the double angle formulas, probably in this case anyways, well, as far as in the 2x. But again, like what we're trying to identify, like for this formula, again, is we're trying to find the solution. So we don't want to use the inverse tangent, right, to undo tangent of x. Again, we're trying to find the solutions. And remember, there's infinite many solutions. That's why the inverse tangent doesn't work. That is, that's not going to provide us all the solutions that make this equation true on the interval 0 to 2 pi. So basically what we want to do is, we're dealing with the double angle, is we want to find all the solutions total. So we think about this graph, you basically have this tangent of 2x the graph, and then where's that going to cross square root of 3 over 2? Or if you think about this on the unit circle, let's see, the unit circle is over here. Square root of 3 over 3, hopefully my students remembered that's going to be at my angles of pi over 6 and 7 pi over 6. Now again, remember tangent is only positive in the first and the fourth quadrant. And these coordinate points, if you take the y coordinate over the x coordinate, you can see that that would be a positive square root of 3 over 2. And this would be a positive square root of 3 over 2. So you can see how those 2 points, when you take the y over the x, equals. Whereas these 2 points, the 5 pi over 6 and 11 pi over 6 would be negative. All right, so now, again, you can see that these are pi away from each other. I don't need to add pi to each of them. You can see that they are pi away. So as far as all my solutions, that's going to be, all I'm going to do is say, so I'll say 2x is equal to pi over 6 plus pi n. Then I'll just divide by 2, and I can say x is equal to pi over 3 plus pi halves n. Thank you, Polynomas Alma. You caught my attention with your super chat. Thank you so very much. I'm not planning on doing my open Q&A for this, but since you did a super chat, I obviously feel obligated to answer some questions. I am going to finish this quiz for you, but then if you can just kind of let me know what you want me to cover on the unit circle. I did respond to your community post, so I'll be happy to go over it tonight, or I can go over it now after I'm done with the quiz. But just kind of let me know what you'd like me to explain or go over with that, and I'll be happy to do that for you. I do appreciate the super chat. Thank you. All right, but again, like in this portion, what we're trying to do, guys, is not trying to find all the solutions. We're trying to find the solutions between 0 and 2 pi. So therefore, now we're just going to take intervals of n. So when n is 0, I have pi over 3. When n is 1, I'm adding pi halves. Now, in terms of thirds, pi halves would be so 1 pi halves. So therefore, you can just add pi halves plus pi thirds is going to be, let's see, we're going to multiply that by, why am I like blanking out from this? For some reason, I guess when I did my quiz, I did it so long ago, I'm like, forgot. I'm not remembering that I did all of this work being exactly the same. So it's just kind of like weird for this case. So pi over 3 is not going to work. So we're just going to have to add that. So let's go ahead and do the fraction here. So pi over 3 plus pi halves. So you can multiply these by 2 over 2. I just don't remember doing this when I made my key, but I guess that is, so that's going to give me a 5 pi over 6. Maybe I did do this. I just forgot. When n is 2, that gives me pi, which is 3 pi over 3, which is 4 pi over 3. And then if I had n is 3, that'd be pi over 3 plus 3 halves. So it'd be pi over 3 plus 3 pi halves. So again, doing the same thing, multiplied by 3 over 3, multiplied by 2. And again, my largest number is going to be 6, right? 6 pi over 3. That's, for instance, on 2 pi. And let's go ahead and see here. So if I multiplied by 3 over 3, well, that's not going to work anymore, right? You can see, actually, yeah, and that would be 6 and 5. So that one works, 5 pi over 6. Oh, no, I get to 12. That's fine. I 12 pi over 6, not 6 pi over 6. I'm going crazy. Yeah, I think the answer was, so that becomes 9, 11 pi over 6. I think that sounds familiar. Okay, so again, all they're doing when you're trying to find these solutions here, what you are doing is you're finding all the solutions to find the interval, and then basically I'm just plugging in, I'm just taking pi over 3, my first solution, and I'm just adding additional elements of n. So when n is 1, n is 2, n is 3, and that becomes the largest I could, because when n is 4, that would be 2 pi, and you can't, obviously that's going to be, we need to only find the solutions between 0 and 2 pi, so taking a solution, adding 2 pi to it is going to be larger than we can cover. The next one is find all the solutions to the equation sine squared of x minus 2x equals negative 1. I think I actually did this in my notes for the students. I just rearranged it a little bit. But again, like remember guys, when you have more than one trig function, set them equal to 0, right? So sine squared of x minus 2 sine of x plus 1 equals 0. Like I think we did this in my class, like in for notes. So, but the main thing is, students did a whole bunch of stuff. They divided by 2. They took the square root of both sides. They did not recognize that we needed to solve this like a quadratic function. Like this is x squared minus 2x plus 1 equals 0, right? So again, when you have more than one x, you got to get them all to the same side to set them equal to 0. So therefore, you can either factor or use the quadratic formula. We're not using the quadratic formula here, but that's the idea, is to have the set equal to 0. And we want to apply the zero product property, which we recognize this is a binomial squared. Okay, so we want to do the same thing here. We're just going to replace x with sine of x. So therefore, I have a sine of x minus 1 squared equals 0. So therefore, you take the square root of both sides, and I get a sine of x is equal, I'm sorry, let's do this. Sine of x minus 1 is equal to 0. So therefore, sine of x is equal to 1. And then basically, we want to find all the solutions. Well, the solutions when sine of x is equal to 1 is going to be the angle pi halves, right? It's going to be right here. So therefore, all we're going to do is going to take this angle. So we'll have x equals pi halves. And then again, to keep on getting these solutions, we're going to have to add 2 pi m. Okay, so let's go and take a little break. And then what I'll do is I'll get into the multiple choice questions, and I won't take too long from that. We'll kind of do that rather quickly because I'll show you guys exactly exactly what we need to do there. So, all right, so I do like this new dashboard from on there. So unable to check your chats. Why not? Let's check my stream health. Oh, seems like my audio is a little rough. Sorry about that, guys. Now it's saying that everything's low. Interesting. All right. Kind of weird. Okay, well, I'm just going to continue on with this stream, guys. I'm not sure why my chat has like now been disconnected. Said everything else was going through, so I'm just going to say still going. I don't know. Odd. All right, so let's just go ahead and let's wrap this up, and then I will do some work. And yes, polynomials, I'll still go ahead and talk about the unit circle. Maybe I'll just at least create, do something at least for you, kind of get you started on that from there, and then we'll kind of go from there. So the next thing, so let's just go and look through these, and then I'll go over talk about the unit circle. So it says, what are the first 4 positive solutions of the equation sine of 2 theta equals 1/2? So in this case, all we want to do is think about 1/2, like when is sine of theta going to equal 1/2? Well, it's going to equal 1/2 here and here, right? And those two angles is pi over 6, as well as, so that's going to be pi over 6, as well as 5 pi over 6. Okay, now again, if I was going to divide those by 2, like obviously there's more solutions to this because you have to do pi over 6 plus 2 pi n. Actually, let's just write out all the solutions because that's what we would do step by step. If this was a free response, we'd do 2 theta equals pi over 6 plus 2 pi n, as well as do 2 theta equals 5 pi over 6 plus 2 pi n. All right, but we're not going to solve all the solutions because really I just want to do the least amount of work then so I can still go continue this. And what I notice is when I divide by 2, I'm going to get a pi over 12, right? And divide by 2, get a 5 pi over 12. Now, obviously, there's more solutions here because you have to keep on adding pi into it. But the only answer that is divided by 12 is going to be B. So I'm just going to roll with that and move on. The next one, just doing a little distributive property here. I recognize secant is cosines in the denominator, right? 1 over cosine. And cotangent is cosine over sine. So when I apply this, I'm going to have a 1 over sine, and then plus a sine over cosine. So that'd be plus a tangent of x. So I recognize that 1 over sine is cosecant plus tangent of x. That answers B. The next one is just needs to be simplified. So see, all right, cosine over sine is going to be a cotangent squared of x, and cosecant of theta times sine of theta is going to be plus 1. So multiply those plus 1, and therefore using my Pythagorean identities, I can see that's going to be cosecant squared. BB. Yeah. Okay. The next one is going to be, that's going to be 1, and that's cosine over sine, which is cosine. The next one, number 8, is going to be complete the identity. Now, this one looks pretty confusing, right? I have something to the 4th power minus 2 times secant squared, tangent squared of x, plus tangent to the 4th of x. And it's like, whoa, what is that going to be? So sometimes it might be helpful. You know, one thing I told students to do is just like write things in terms of x's and y's. Like this would be x, this would be an x squared, y squared plus y to the 4th. Okay? And if you do it in these x and y's, maybe you might recognize that this can be rewritten as a perfect square trinomial. This can be x to the 4th, let's see, minus y to the 4th squared. No, that's not it. X squared times y to the squared. My bad. There you go. Yeah. So this is going to be x squared minus y squared squared. So this is a perfect square trinomial because the first 2 terms are square terms, the second 2 terms are square terms, and the middle term is a sum of the times 2 of those 2 terms. So now I really just recognize this. If I'm going to replace this, then I have it's really a secant squared of x minus a tangent squared of x squared. All right. Now, again, understanding my Pythagorean identities here, I recognize that 1 plus tangent squared of x is going to equal secant squared. So you could write everything in terms of secant, or you can write everything in terms of sine. It doesn't really matter. But if you wanted to rewrite tangent here in terms of secant, then you could rewrite this here as a secant squared of x minus a secant squared of x minus 1 squared. Well, when you subtract these, you end up getting a 1 squared, which is just equal to 1. So that answer is A. And then last but not least here is we have another solving one. It says find all the solutions in the interval 0 to 2 pi for the equation 2 cosine theta minus 1 is equal to 0. So in this case, all I'm going to do is add 1. Actually, you know what? I'm just going to get to this point. So this is going to becomes a cosine squared of theta equals 1/2. When I square root this, I've done this a couple times in my class already. I know my answer is going to be square root of 2 over 2. So, and again, sorry, that's going to be plus or minus. So I know when that is going to equal, I have to do not only the positive versions, you know, pi over 4 and 7 pi over 4, but I also have to do the negative versions, 3 pi over 4 and 5 pi over 4. So therefore the answer in this case is going to be C, which is going to represent all of my solutions. All right, so I'm not sure why my chat has been disconnected. I'm hoping the audio, guys, is not that bad and I need to redo this, but at least I have a key out of it from now. So let me just kind of go over this polynomials for my algebra here. And basically all we're simply going to do in this case is, you know, I'm not really sure what I need to cover, but really let's just kind of go through the memorizing and maybe like evaluating a couple. So the unit circle, remember, is just made up of our 30, 60, 45, 90, 60, 30 triangles. Okay, so it's just right triangles. And the main important thing is understanding these corner points. So if you just take your 30, 60, 90 triangle And in this case, you could rearrange the 30, 60, 90 long ways like this, or you could do long ways going like that. And then the main important thing, the thing that's special about the unit circle is the hypotenuse for all of those triangles is 1, right? And so, or the radius of the unit circle is 1. So that gives us this point as 0, 1. That gives us this point as 1, 0. Now, if you were to use these 30, 60, 90, 45, 45, 90 triangles, if you were to find all the sides of the triangle when the hypotenuse is 1, you would get these lengths, right? This, whatever the side length is the x-coordinate of this point. Whatever the side length here is the x-coordinate of that point, and the side length here is the x-coordinate of that point. And the same thing works for that other side length. So really what we do is when we're introducing the unit circle, I have students, find those side lengths of the special right triangles. But then there kind of comes to the point where it's like, all right, how do you memorize, those points, like what exactly they are? And the easy way to remember it is really, the square root of 1, square root of 2, square root of 3, square root of 1, square root of 2, square root of 3. And then everything is divided by 2. Okay, so that is the creation, or at least the creation of the unit circle. And then now the next thing really kind of comes into, well, how do you evaluate everything for the unit circle? So remember, basically, the unit circle, to evaluate using the unit circle, is basically taking this first quadrant and putting it on an XY grid. So again, we have these points, and we can basically now we can remove the triangles from there, and we can just look at these x and y coordinates, because now that the hypotenuse is 1, when I take the adjacent side over the hypotenuse, it's over 1. So I can just use the adjacent side, which is the x-coordinate. So that's why we say the cosine of an angle is the x-coordinate. The sine of the angle is the y-coordinate. But it's not really just the x and y-coordinate. It's really the opposite over the hypotenuse. Just the fact that the hypotenuse is 1, that's what makes our life a little bit easier. So now you could do everything in terms of degrees or in radians. And in my class, we mainly focus on radians, so that's what I'm just going to do here. So this would be pi over 6. This angle is pi over 4. That angle is pi over 3. And this angle is pi halves. Okay? So that's basically how we use those angles. The only thing I'm just going to show you is, now, so if I say, what is the cosine of pi over 6? All you're going to do is look at the x-coordinate. Oops, I forgot to do. Which is, all you're going to do is look at that x-coordinate, which in this case is going to be x-coordinate, which is going to be square root of 3 over 2. Okay? So there's one example. The next example is, what if I said the cosine of, 7 pi over 6? So the interesting thing about 7 pi over 6 is we need to understand what the reference angle is. So 7 pi over 6 is just a little bit over pi, right? So what we do is, what I like to do is tell students, all right, find the reference angle, which is pi over 6. The reference angle pi over 6 is basically going to tell you the value in the first quadrant, or what that angle would be. So we go again, we'll go pi over 6 and say, oh, that's square root of 3 over 2. Yeah, but the angle is actually in the third quadrant, and cosine is negative. Like the x-coordinates are negative in the third quadrant. That's why that is a negative square root of 3 over 2. So when you have a triangle when you have an angle that's in the first quadrant, remember cosine is x, sine is y, tangent is y over x. When you're dealing with points that are outside of the first quadrant, then basically what you want to do is find the reference angle, evaluate the trigonometric function based on the first quadrant, which you should just know, and then go back, find the angle find the quadrant that your angle is in, and apply the correct sign. So hopefully that helps you for what you're looking for on the unit circle. Otherwise, guys, I'm not sure what happened to my chat. Again, this is my first time actually going live on this new software, which I eventually am going to have to do all of my lives on. So I wanted to just at least get that started, or at least get that squared away. But just a reminder, I will be going again live tonight. So if you do have some questions and you didn't get to them, or I didn't get to any questions, but if you do have some questions and you'd like to submit those, please feel free to join on the community chat, and I will see you guys on the live stream tonight. All right, cheers. Well, let's see if I can turn this off the correct way. So I'm finishing that one.